Hey there, geometry friends. Geometry friends. Wait, this is algebra. Oh my gosh. Hey there, algebra friends. This is right here. Algebra. Today we're going to take our linear equations that we've been working on in the last couple of days and take it to the next level, where we're going to do what's called a linear piecewise function. So the idea behind a piecewise function is there are several different pieces. So a piecewise function is the graph separated in two pieces. Pieces or parts. Each different part of the graph is written across a different set of x values. So each different part of the graph has its own domain, its own range of x's where the graph is drawn. Our piecewise function notation looks like this stuff that's right here in the middle of your page. There's your piecewise. So the name of the function is the f, and then you're going to see two, three, maybe four different parts, and each different part of the graph has its own equation that it follows. And each different part of the graph will have its own domain. The domain will be written in inequality notation. And remember, the domain is the x's. Okay? Because our domain will be using inequality notation, we'll have the difference between open circles when we have the less than symbol or the greater than symbol, and then closed circles if it's less than or equal to, greater than or equal to. You'll also see open or closed circles on the graph, just like when we use these inequality symbols, it would dictate whether we draw an open or closed circle on the graph. So we'll have to show using the inequality symbols in the domain equation, whether it's open or closed, and then on the graph also when it's open or closed. And the reason why we need to make sure we have the open and closed correct is because all functions must pass the vertical line test. We did that this year. It was an 8th grade standard. Don't know if you actually did it in 8th grade, but I know we did it already this year. And I know because I was there and I taught it to you. So let's take a look at an example here. Now it's not in different colors on your paper, but it is different colors on mine. So you can kind of take a look and see the picture on the graph. Start out with the easy question. How many different parts or how many different pieces do you see on the graph? There's a blue section on the left, the red flat section in the middle, and this green section on the right. So there are 3 pieces to the graph. The left side, which is the blue end, comes from negative infinity because it's going down forever. And as I read from left to right, that blue section stops when x is -1. So the inequality notation to describe where each piece starts and stops, that's our domain. And our domain for the left side of the graph would be all the x's that are less than or equal to -1. So all this from this x to the left follows that graph. So all the x's that are smaller than -1 follow this blue graph. That's the blue section of our graph. Okay. Next, in the middle, we have this red section that goes from -1 to +1. So the x's go from -1 to +1. Now remember that our function must pass the vertical line test. So in order to pass the vertical line test, I need to make sure that there is no overlap between the two different sections. So since I used a closed circle here and made it equal to -1 on the left part of the graph, I am going to leave it as an open red circle. And then I have the choice of either to close it or leave it open for the other end around +1 because I haven't written the right side of the graph yet. I just need to make sure that I adjust my symbols so that it's not equal to 1 in two different parts. So I made it equal to 1 on the left side, but not equal to -1 on the middle piece. So it is equal to -1 on the left piece, but not equal to -1 on the middle piece. So for the third piece, that's over here on the right edge of this graph, I'm going to make it not equal to +1 and then head towards infinity to the right. So as I go sideways to the right, it'll go forever. So these x values are all x's from 1 and to the right, so x's that are greater than 1. I do not make it equal because I already made it equal in the middle section. So it is equal to +1 here, not equal to +1 here. That way I don't have any issues with my vertical line test. It is still a function. Okay, so we have 3 pieces to the graph, 3 different explanations using my domain, using the x values, 3 different descriptions of where it is drawn. Okay, this graph, our next example, has only 2 different pieces. The left side has a closed dot at negative, where x is -4, and another closed dot where x is +1. So that means the left side of my graph starts when x is -4 and then stops when x is +1. So that section of the graph is from -4 to +1. The right side, the next section, starts at +1 but stops when x is 2. I'm sorry, when x is 3. So this one starts with an open circle at 1 and stops at a closed circle at 3. So for this section, it starts at 1 but not included, so it's an open circle at 1, and then closed circle when x is 3. So that is the 2 sides or the 2 pieces of our piecewise function. This section of our equation is the domain because it is describing where the x values are drawn, or what x values are used where the graph is drawn. Okay, so now let's try to graph one ourselves. There's 2 pieces to our graph, so we have 2 different equations to work with. So our domain tells us where to draw those pieces. So I have that piece, and separately we have that piece. So that's 2 different pieces that we have to work with. To help us do this, we are going to use, I'm going to show you how to get a table of values, and we're going to use the calculator. Okay, so pause the video. If you if you don't have a calculator with you, or you didn't pick one up, go get a calculator. So pause the video, go get a calculator. All right, so when you have your calculator, if you hit this button that looks like a calculator on the left-hand side, it'll toggle back and forth between your scratch pad that you can do calculations on and your scratch pad that is a graph. And you might have this f of x shown and you might not. That's okay. I'll show you either way and help you get what you need. All right. So what we are looking to do is take the equation negative x plus 4 and graph it along the domain from negative 2 to positive 2. So what we're going to look at is the left end of this graph will be a closed circle around negative 2. That's the first x value that we were going to look up. Then we're going to continuously draw this all the way up until x is positive 2. So we need to go from negative 2, negative 1, to 0, to 1, and 2. At the negative 2 end, we'll have a closed circle because it can be equal to negative 2. And at the positive 2 end, we'll have an open circle because it cannot be equal to positive 2. So we'll put an open circle there. To get these values, similar to what we have done in the last unit, and we've done it a little bit here, we are going to plug in negative 2 in for the x and figure out the y value. Okay, so we're going to plug in negative 2 in for x, and we're going to figure out the y value. So if we go back over to our calculator, over to our regular calculation screen, our equation was negative x plus 4, and we are plugging in negative 2. So that's going to look like negative x, which is replaced with the negative 2, and then plus 4. Enter, and we get an answer of 6. That means the first number in my list over here is 6. Now I go do the same calculation, only instead of plugging in negative 2, I'm going to plug in negative 1. So back over to my calculator. I have a negative x, and then plus 4. And that goes to 5. All right, well, that's pretty easy. So now I write 5 here. Pattern is very simple. Looks like the x's are going up by 1s as the y values go down by 1s, which makes sense because that's our rate of change. That's our slope, negative 1. So that means the next number would be a 4, the next number would be a 3, and the next number would be a 2. I have to remember that when I'm graphing this, I do a closed circle around negative 2, 6, but I do an open circle around 2, 2. So let's graph those points. Negative 2, 6, closed circle. Negative 1, 5, 0, 4, 1, 3, 2, 2, open circle. Now we are supposed to connect the dots from negative 2 to positive 2. Do not go past it. It starts at negative 2 and stops at positive 2, so that's all that I draw. That's it. That takes care of the left side of my graph. Now we're going to go through the same process with the other piece, the right side of our graph. This graph will be graphed from positive 2, including positive 2, up to positive 5. So from 2, 3, 4, stopping at 5. Closed circle around the 2 because it can be equal, and a closed circle around the 5 because it can be equal again. So we're going to go to our calculator. We're going to plug positive 2 in for x. So the equation was 2 times x, and then subtract 3. And it gives us an answer of 1. Now we're going to do the same thing. We're going to do 2 times 3 minus 3. So now we're going to put in 3 in for where the x was. So it's 2 times 3. And then subtract 3. And it gives us 3. Okay. And we're going to do it again. Now we're going to plug in the 4. So it's 2 times 4, then subtract 3. It gives us 5. And sometimes you'll see the pattern, and then you can figure out what the next number would be. But you should double check with your calculator. So the next one would be 7. So closed circle around 2, 1, closed circle around 5, 7, and connect the dots in between. So 2, 1, closed circle, 3, 3, closed circle, 4, 5, closed circle, and then 5, 7, closed circle. And those get connected. Do not go past the dots. You must start and stop exactly where it said to. So you start at positive 2 and stop at positive 5. So those are our two pieces to our piecewise function. So the next part is evaluating function notation in a piecewise graph. So, okay, find f of negative 1. I'm sorry, f of 1. F of 1 means to find y when x equals 1. That's what that notation is telling us. Find the value of y when x is equal to 1. So do it from the graph. Go to where x is 1 on the graph. That falls into the blue section. So when x is 1, the y value is at 3. So f of 1 is equal to the y value of 3. What about when f is 2? Well, when f is 2, it means find y when x equals 2. So now we're going to go to the graph, find where x is equal to 2. There's where x is equal to, uh-oh, we have two dots there. So which one do we use? And the answer is you use the closed dot. So when x is 2, the closed dot is at a y value of 1. So that means it's 1. All right, let's try again. Do another one. Again, we have two pieces. One piece when x is smaller than 5. The other piece will be when x is greater than 5. That'll be our two pieces. When we're doing this, we can make the table of values to figure out where to graph it. But I'm going to show you how to do this on the calculator. All right, so get your fancy calculator out. Get it warmed up, turned on, recharge batteries, make sure they're good to go. And get your listening ears on. Okay, so you're going to go to the graph. You just push this button that looks like the calculator, and it'll toggle back and forth between graph screen, calculator screen, graph screen, screen, calculator screen. Then we're going to go to menu. Then we're going to go to option 3. And we are graphing a function. Okay. The left side of our graph, if you remember correctly, that's the blue one, is negative x plus 5. You want to graph that for all x's that are smaller than 5. So negative x plus 5 is the equation we are typing in. So make sure you use the negative sign, not subtraction, the negative sign. Negative x add 5. Now when you hit enter, it's going to graph the whole line, the whole thing. We don't want the entire line graphed. We only want the x values that are smaller than 5. So what we're going to do is go to the table. Now, once you have your equation typed in, you control the table on the calculator by touching the control button and then touching the T button. Control the table, control T. And then look, we have a table of values. This is the calculator plugging in all the numbers for you and then just giving you the list. We need all the x's that are smaller than 5. So when x is exactly equal to 5, our y value is 0. We need the numbers that are smaller than 5, so then it's 4, 1. When x is 3, y is 2. When x is 2, y is 3. When x is 1, y is 4. We are basically graphing part of this line onto our paper, and we are going to follow the values that count down from 5. So, if I remember correctly, when x was 5, y is 0. So when x was 5, y was 0. When x was 4, y was 1. So when x is 4, y was 1. When x was 3, y was 2. And when x was 2, y was 3. And we know from the picture that this is a straight line. So once we get a couple dots plotted on our paper, we'll know what to do from there. Our first circle is supposed to be an open circle when we get to the 5. We are not allowed to use 5 on this part of the graph. So at the point 5, 0, open circle. Next point is 4, 1. I know it's weird that we're going backwards, but remember, we're supposed to be graphing the points that are smaller than 5. So there's the first 4 points that we have in our table. Recognize the pattern of what's happening. We're just going diagonal up through the boxes, which matches the picture from the calculator, and it goes forever because we are doing all x's that are smaller than 5. So that means it's going to negative infinity. For the next piece, we're going to go back to our calculator. This time we're starting at 5 and counting up. Okay? And we're going to have a closed circle when we start. So it's open at one end, and it'll be closed on the next end. So back over to our calculator. Now, if you can do it, you can use your keypad to try to get your cursor right above where the equation was, and then you're going to double click. And you should be able to delete that old equation and type in the new equation, which is x subtract 5. And when you hit enter, notice the numbers in the table change. That's our new table. We are trying to find the x's that are bigger than 5. So I'm going to scroll down. 5, 0, 6, 1, 7, 2, 8, 3. So our x values count up by ones, and so are the y values. So I go back over to my paper. When x was 5, y was 0. When x was 6, y is 1. When x was 7, y is 2. So when x was 6, y was 1. When x was 7, y is 2. When x was 8, y is 3. Now notice that our open circle is now going to get filled in with our closed red circle. That's totally okay. It still makes it a function. And then 6, 1, 7, 2, 8, 3. Following the pattern, it would be going up to the right. There is our piecewise function. And it passes the vertical line test because the blue circle was open. Then we filled it with the red circle that passes the vertical line test. So to find f of 5, that means go to your graph. When x equals 5, then f of 5, which is the y value, is at 0. If f was negative 10, that is off our graph. So we're going to have to use the equation. Now, if we're talking when x is negative 10, which piece would I use, the blue or the red? Would negative 10 fall in the left side of the graph or the right side of the graph? Well, negative 10 is all the way down here. So that's going to follow the blue part, which is the left piece of my graph. So that means I'm going to take the equation negative x plus 5, negative x plus 5, replace the x with the number negative 10, and then just figure out what number do I get. So when you negate a negative 10, it turns positive, and 10 plus 5 is 15. So f of negative 10 is equal to 15. Ah, this one. 3 parts to it. Now we're going to do a 3-part function. Okay, take a deep breath. Here we go. Yeah, 3 parts to this one. 1, 2, and 3. We can do a table with each one. We just have to be careful which y values we're using. Okay? So, the first one, the blue one, is all the values of x that are smaller than 2. So that means 2 is the largest number. And then count down from there. In the middle section, we're going from 2 to 5. So 2, 3, 4, 5. And the last section goes from 5 to 7. 5, 6, 7. So those are our 3 pieces. We got the blue piece. That'll be on the left end. The green piece, that'll be in the middle. And the red piece, that'll be on the right end. So what we can do is on our equation, in our calculator, we're going to change x minus 5. We're going to double click on that box, and we are going to change it to the left piece which was negative 2x plus 3. Remember, if I'm going too fast, guys, just pause, type it in, and then come back. When you hit enter, the table will change. And then we can just fill in the numbers from the table right there from our calculator. So you have the advantage of being able to look at your calculator and your paper at the same time. So you can do this a lot faster. But I'm going to fill in my numbers real quick because I actually have them written down next to me here. So on the table, when x was negative 2, I just need to scroll. When x is negative 2, the y value is 7. So when x is negative 2, the y value is 7. From the calculator, when x is negative 1, the y value is 5. When x is 0, the y value is 3. When x is 1, the y value is 1, and then to negative 1. As I go to graph it, make sure that I'm using the appropriate circles. This can be equal to exactly when x is 2, so I'm going to have a closed circle there. So I'm going to go 2, negative 1, 1, 1, 0, 3, negative 1, 5, and negative 2, 7. Now, our graph will be graphed for all x's that are smaller than 2, which means it will go to negative infinity, and I need an arrow there. It stops at positive 2, but heads towards negative infinity. All right, the next section of our graph. This may look a little weird because it says y is equal to negative 1. Well, we did some practice the other day when you have the equation y equals negative 1. That means anytime you have an x value, your y value is negative 1. So for any x value, your y value is negative 1. No matter what x value you pick, your y value is negative 1. Even if your x value is 5, your y value is still negative 1 because it says right here, y is equal to -1. So open circle at each end because it cannot be equal. And let's plot some dots. So 2, -1 puts an open circle where the blue dot was filled in. And then 3, -1, 4, -1, 5, -1. Oops, look at that. That's supposed to be an open circle at 5, -1. Connecting those dots, that's a horizontal line, as it should be. There's our middle piece. And then the other end is 2x subtract 6, so I can do that on the calculator. Double click where my equation is and change the 2x, change to 2x subtract 6. When I hit enter, the points will change. There's my new table of values, but I need to graph these values from +5 to +7. So I just need those three numbers, where x is 5, where x is 6, and where x is 7. Okay, so when x is 5, our y value is 4. When x is 6, the y value is 6. When x is 7, the y value is 8. So 5, 4, 6, 6, 7, 8. So 5, 4, 6, 6, 7, 8. Closed circle around both ends and just from one dot to the other. So there is our three pieces. So to do some evaluation on this graph, go to where x is -2. When x is -2, our y value is 7. Now go to where x, so when x is -2, y value is 7. When x is +2, where is the closed circle? And that would be at -1. Next, we go to where x is +4. When x is +4, our graph is drawn at the y value of -1 again. What about when x is +5? Well, when x is +5, I see two positions that I could read, but you go to the closed circle that is all the way up here at 4. Explain why there can't be a solution where the function, for the function when x equals 10. If you look closely at what we graphed, our graph stopped at an x value of 7, so there is no more domain or graph beyond that x value. Our graph stops at an x value of 7. There is no graph when x equals 10 because it is not in the domain. That's why there can't be a solution there. The graph is not defined there. And finally, our Regents multiple choice question. When the function g of x equals 5x when x is less than 3, or x squared plus 4 when x is greater than 3, when it's graphed correctly, how should the points be drawn on the graph for an x value of +3? When x is +3, it'll be a closed circle there. It will be an open circle there. So let's figure out what's the y values at those two spots. When x is 3, then our 5x function is 15. So that means closed circle at the point 3, 15. When x is 3, the other graph gives us a y value of 313. So that would be an open circle at 313. So now let's look at our choices. Find the right choice, circle it, and then you can go work on your practice. So if we read through these choices, open circles both, no. Closed circles both, no. Open circle at 315, that's not what I said. I said closed circle at 315 and an open circle at 313. There you go. Adios, friends. Have a wonderful day. Thank you for playing along.